Moin, this is Timo Buske, I work for KDEP and I want to give you an overview of how to prepare 3D models for real-time export. Okay, I opened up my 3D scene here, and the thing you are going to spend the most time on is optimizing the meshes. So let's go through some of those meshes and see what we can do here. I'm using Blender for this, since this is free and you can try out for free. But all the tools I'm using are also available in other 3D applications like 3ds Max or Maya, you name it. So it shouldn't be a problem to do this in other 3D applications as well. So let's start with the sunroof here. You always have to consider where your camera is in the 3D in your application you are building later. So can you view those meshes from both sides, or maybe can you leave out one side and some faces for this? And which platform you are running on. So is it a desktop, a top-notch desktop 3D with the latest NVIDIA card? Or is it just a ES2 device? So for example, for an ES2 device, depending on the driver which is running on that device, could be the case that your vertex number is limited to 65K, so you would need to split up the meshes additionally. But for this tutorial, let's pretend we are going to create an app for a desktop PC. So let's see. Currently the sunroof has about 500 faces. It's two-sided, so it's a closed volume, so to speak. But in my application, I want to view the car just from outside, so I'm going to delete all the inner faces here. And actually this is a smooth surface here, but I can't tell you why there are triangles in here, and this is split up, so we will remove this one, those faces here as well. So let's start with the inner faces. So I just now selected this face loop here, and I'm going to remove those faces. And now it's easy to remove the inner faces just by growing the selection, because they don't have any attachment point to the other faces I still need. So I can easily remove those. So the next thing I'm going to do is to care about this triangulation here. We don't need those faces in the middle because it's a smooth surface going from here to here, and these faces doesn't make any sense, so we are just going to remove them. For this I'm going to select those vertices here and collapse them to their own center. With Blender this is WMC. So this could be a bit problematic here, so I'm just going to remove the faces and build my own later. So I'm going to select those faces. Remove those. And then I can just collapse those vertices here as I did before. That didn't work, so I need to build faces for this first. with F. Additionally, I can remove those leftovers from our removal here, those vertices in the middle. I'm just selecting them and hit dissolve vertices. So the last thing I want to do is to remove even more edges, because this edge down here is completely hidden by other objects and we don't need it. So I'm going to select this edge loop here. This is done by pressing Alt and selecting one of the edges. And as you can see, the selection goes completely around the object now. And as we did before for the vertices, I just can dissolve this edge. Okay, this should be sufficient, and as we can see, we went down from 500 faces to 164, which is quite good. I think we can leave those triangles here because yeah, we can't do much about this. So I think for the sunroof, this is okay now. Okay, the next object I would like to tackle is the hood. So I'm going to select it and hide all other objects. And let's take a look at the mesh. So we see a problem here because the mesh resolution in this direction is okay, but the mesh resolution in that direction is rather coarse. So you would see that later in the reflections. So what we are going to do here is we are going to increase the overall mesh resolution and later manually reduce it again where we need it. So let's see, we have now around 4K faces. Let's add a subdivision modifier. We are lucky in this case because the mesh is built in a way so we can apply a subdivision modifier, but if you import meshes from somewhere or get an export from a CAD application, for example, that might not be the case. For example, if there is a irregular triangulated mesh, but in this case it works out right out of the box. So I'm going to apply this and you'll see this is much better now, but it's a lot of faces like 15K. And we don't need so much edges and so much faces in those areas here. Okay, so since this is symmetrical and I don't want to do everything twice, I'm going to throw away half of the vertices. Okay, let's remove those as well. Alright, so now we have one side of the mesh. We will mirror this later. And now let's reduce the mesh resolution where we don't need it. So we are going to use the same technique as before. we go to the edge mode and select some edge loops we don't need. And we can dissolve the edges, so the faces are persisting. Especially in those areas which are completely hidden by other objects, we can reduce the mesh resolution drastically. So that seems okay to me. Let's now mirror and add the missing faces. Okay, for the sake of this tutorial, that should be it. We could reduce even more here, but we went from slightly below 4K to slightly above 4K, and keeping almost the same face count, we now managed to get a much better mesh for reflections, so all the quads are in a much better aspect ratio. You don't see the polygons here anymore, and I think we are good to go to use this for real-time 3D now. There's one thing I wanted to show you. Please stay away of using those automatic mesh reduction tools because you absolutely don't have any control over the mesh. Let's apply one of those to this mesh and hit apply. And as you can see, we went from our beautiful regular quad mesh to an uncontrolled triangle mesh, and you definitely will see this later in the reflections in your real-time application. Okay, as we now know how to optimize meshes, we need to go around the entire car and do this for all the meshes. If with that, it's time to apply the materials. I already prepared some materials, so I just need to apply them to the meshes. And remember, it's important for Kuesa to have exactly one material per mesh. So that's it. Let's export to GLTF and give it a try in the GLTF editor. I now fired up the Kuesa GLTF editor, and let's open up our GLTF export. Yeah, it seems to work out pretty well. We could tweak the materials a little more so it looks more realistic, but this shouldn't be part of this tutorial. So let's switch back to Blender and see what we can do more. Sometimes mesh is not everything. You also need to consider the normals. For example, if we look at this object here, we see that there's just one normal per face instead of one normal per vertex, which are interpolated. So this will result in this flat shading. You can easily switch that by applying smooth shading. This is similar in other 3D applications as well. But sometimes you will have a problem since you can set each edge to remain sharp even if smooth shading is applied. This is what happened here for the exhaust. So if I would apply smooth shading here, you won't notice any difference. So in order to make this work, we need to remove all the sharp edges. So I'm going to edit mode, select all edges, and clear the sharp flag for all the edges. So now this is smooth, but we wanted to have those edges here at the end of the exhaust to be sharp. So let's again switch those edges to sharp. We already know from the mesh optimization step there is a convenient way of selecting the edge loops, which we are going to do now. We mark those as sharp. Same for those. And same for the other side. Of course, we could have done, oh, there is already a mirror modifier on it. So we are done for this. If you are dealing with transparent objects, you need to consider the pivot of the object, since transparent objects are rendered sorted. And they are sorted by their pivots. So it's not a good idea to just put all the pivots to one point, because then they can't get sorted. So especially for those transparent objects, let me get one of those. You can see here the pivot is in the middle. And in most of the cases it's sufficient to just put the pivot in the center of the mesh itself. Like this. In Blender you can do this by selecting the object and pressing Ctrl Alt Shift C and choose one of those options, for example origin to center of the surface. The next thing we need to do is to clean up the scene. We need proper naming for all the nodes and the meshes, so the developer is able to retrieve those by name, and we need a clean scene hierarchy. Let's start with the names. After renaming and cleaning up the objects, I'm going to create the scene graph. I'm going to do this as simple as possible. For my app, I just want to be able to open and close the front doors. So I'm going to create 2 empties for that and maybe 1 additional empty for all the remaining objects. I'm going to duplicate this empty for the other side. And I'm parenting all the objects of the left door to this empty. Same for the other side. So I should be able to rotate now the doors around the new empties. Works. So for the rest of the objects, I'm just creating a new empty. At the origin. And I'm going to parent all the remaining objects to this empty. I'm going to name this one car, that one door right, and that one door left. And I'm also parenting those empties to the main empty. Okay, that should be it. I now can move the car with the main empty and place it somewhere in the scene. And I additionally can open and close the doors with those empties and animate them, of course. Okay, that's it for the tutorial. It's obvious that we can cover all topics in such a short amount of time. The intention of this video is just to give you an overview, and I hope it was useful to some of you. Thanks for watching and see you. Bye bye.